हेलो फ्रेंड्स, वेलकम बैक टू माय यूट्यूब चैनल। इस वीडियो में हम एमएससी जूलॉजी 4th सेमेस्टर सब्जेक्ट बायोकेमिस्ट्री का लिपिड मेटाबॉलिज्म का स्टडी करेंगे, जिसका इंट्रोडक्शन है। लिपिड मेटाबॉलिज्म रिफर्स टू द बायोकेमिकल प्रोसेस इन्वॉल्व्ड इन द सिंथेसिस, ब्रेकडाउन एंड ट्रांसफॉर्मेशन ऑफ लिपिड इन द बॉडी. Lipids are organic compounds which are primarily made of carbon, hydrogen, and oxygen, and they include fats, oil, and cholesterol. These compounds play a vital role in cellular structure, energy storage, and signaling within the organism. Lipid metabolism is a fundamental aspect of biochemistry, especially in zoology, as it governs essential biological functions and maintains overall health. The body uses lipids for energy, insulations, and as building blocks for cellular membranes. Metabolic processes such as lipogenesis, synthesis of lipid, and lipolysis, breakdown of lipids, are tightly regulated to ensure energy balance and the proper functioning of biological system. This article into the key concept of lipid metabolism include its definition, type of lipids, metabolic pathway, and its role in animal physiology. Definition of lipid metabolism. Lipid metabolism is the process by which lipid, fats, and oil are broken down to generate energy or used to build other complex molecules in the body. It involves both the catabolic and anabolic pathway. Catabolism, breakdown of large lipid molecules such as triglycerides into smaller molecules such as fatty acids and glycerols, which can be used for energy production. And anabolism is synthesis of lipids from smaller building blocks, which are then used to storage, insulations, and cellular structure. Lipid metabolism is essential for maintaining energy homeostasis, supporting growth, and facilitating cellular functions, especially in higher organisms. Type of lipids involved in metabolism. Triglycerides, the most common form of fat found in the body, stored in adipose tissue and used as a long-term energy source. Second, phospholipids, essential component of cell membrane, consisting of fatty acids, glycerol, and phosphate group. Steroid, lipid molecules like cholesterol that function in the synthesis of hormones and as structural components of membrane. Fourth, fatty acids, key building blocks for triglycerides and phospholipids. They can be saturated or unsaturated depending on their chemical structure. Key pathways in lipid metabolism. First, fatty acid synthesis means lipogenesis. Lipogenesis is the process through which the body synthesizes fatty acid from acetyl-CoA and malonyl-CoA. This occurs primarily in the liver and adipose tissue where energy intake exceeds energy expenditure. The process involves several enzymes such as acetyl-CoA carboxylase (ACC) and fatty acid synthesis (FAS), which add 2 carbon units to growing fatty acids chain. Second, fatty acids breakdown means beta oxidations. Beta oxidations is the catabolic process through which fatty acids are broken down into smaller molecules called acetyl-CoA. This occurs in the mitochondria and is a crucial step in generating ATP from cellular energy. Each round of beta oxidations removes a 2 carbon unit from the fatty acid, which is then used to produce ATP through the citric acid cycle. Triglyceride synthesis and breakdown. Triglycerides are found by attaching 3 fatty acids molecules to a glycerol break bond. This process is essential for storing excess energy in adipose tissue, When energy is needed, triglycerides are hydrolyzed by enzyme like lipase into glycerol and fatty acids, which can they be used for energy production. Cholesterol metabolism. Cholesterol is a vital for membrane structure synthesis for steroid hormone and bile acids. The liver synthesizes cholesterol from acetyl-CoA, and it can also be obtained from dietary source. Cholesterol is transported in bloodstream by lipoproteins, including low-density lipoproteins and high-density lipoprotein. Excess cholesterol can lead to conditions like atherosclerosis. Regulation of lipid metabolism. Lipid metabolism is tightly controlled by hormonal and enzymatic regulations to ensure proper balance between energy intake, storage, and expenditure. Hormones like insulin, glucagon, and cortisol play a key role in regulating lipid metabolism. Insulin promotes the storage of lipids by stimulating lipogenesis and inhibiting lipolysis. Glucagon stimulates lipolysis and fatty acid release for energy production during fasting. Cortisol enhances lipolysis during stress and play a role in energy mobilizations. Enzymes such as lipoprotein lipase and hormone-sensitive lipase are involved in the breakdown and mobilization of stored lipid. The role of lipid in animal physiology. Energy storage and mobilization. Lipid, especially triglycerides, are the body's most efficient from the energy storage. They store more energy per gram than carbohydrate or protein. During time of fasting or exercise, stored fat and broken down to release fatty acids for energy production. Cell membrane structure. Phospholipid and cholesterol are essential components of cell membrane. Phospholipid form bilayer and provide structural integrity and fluidity to membranes, while cholesterol help modulate membrane fluidity and stabilize structure. Insulations and protections. Lipid provide insulations to organ and tissue, helping maintain body temperature and protect vital organ from mechanical damage. Brown adipose tissue, rich in lipids, is specialized for thermogenesis, heat productions, especially in newborn and hibernating animals. For signaling and hormone synthesis, lipids such as eicosanoids delivered from arachidonic acids act as signaling molecules, regulating processes like inflammation and immune response. Additionally, lipids are precursors to steroid hormones such as estrogen, testosterone, and cortisol, which regulate various physiological functions. Disorder related of lipid metabolism. First, obesity. Excessive accumulations of triglycerides in adipose tissue due to imbalanced lipid storage and mobilizations. Atherosclerosis. The build-up of cholesterol in the arterial walls, leading to plaque formation and an increased risk of cardiovascular disease. Hyperlipidemia. Elevated levels of lipid in the blood, which can increase the risk of heart disease and strokes. Fatty liver disease. Accumulations of fat in liver cells, often caused by an imbalance between lipid synthesis and breakdown. Conclusions. Lipid metabolism is a fundamental aspect of biochemistry that governs the production, breakdown, and storage of lipids in the body. Lipids play a critical role in energy storage, cell membrane formation, hormone synthesis, and various other physiological functions. The regulation of lipid metabolism is crucial for maintaining energy balance and supporting healthy physiological process. Disruptions in lipid metabolism can result in serious health conditions, highlighting the importance of understanding this biochemical pathway for the prevention and treatment of metabolic disease. A better understanding of lipid metabolism also opens up new avenue for developing therapeutic interventions of disorders like obesity, cardiovascular disease, and diabetes. References: